and you have to evaluate this angle in order to have an error that is lower than the wavelength if you are considering a movement, a real one, of 100 millimeters. Okay? So with this displacement, you are working with a corner cube. Okay? This is the real situation. Okay, so you have everything. So you have defined what is the error. So now, if you want to evaluate the maximum, let's say, misalignment that you can sustain, you can write alpha max. So let's say this is the maximum error. Okay. And you can equate this quantity to the wavelength. Because the exercise asks you to find out what is the maximum misalignment by which the error is lower or equal to a wavelength if our target is moving of 100 millimeters. Okay? How can you do the job? Because, of course, here you have all the data. So we have to do something here. Well, you can do a simplification. You can suppose to work with an angle that is little, okay? So what you can write, this quantity can be equal, if alpha max is low, to 1 minus what? Let's use the first two order of the minus of the cosine function. Is it correct? Yes, is it correct? Yes. Okay. Okay, if alpha is little, you can always write this thing. Okay? Just let's consider what is. So let's suppose that this is alpha, and here you have the cosine alpha. If the angle is low, this is this is 1, and so this curve is equal to 1 minus alpha squared over 2. Okay? This is always true. If you are considering what happens around, let's say, the origin of the function. Okay? And what you can say, so that you can write that here it remains only alpha max squared, and this means that the maximum angle is equal to 2 lambda divided by dLm over the square root. And this is a very little angle, because this is equal to 3.5 milliradian. Okay? So the approximation is good. Okay? And okay, we have still 5 minutes, but I believe that we have reviewed everything, so also something about acceptance, brilliance, and speckle. And let's see, next time we will do a seminar on gravitational wave observatory or interferometer for detection of gravitational waves, and it will probably last 1 hour more or less, so we will have, let's say, 20-30 minutes probably to do another exercise if you want. Okay. But I believe that for today is okay for me. When I say that this is a seminar on gravitational waves, it means that you will not find exercises about gravitational waves. But in my opinion, since this is a very huge result of optical instrumentation, I suggest to you to come, because it's a bit entertaining or amazing, because from the point of view of technological aspect, it's a fantastic discovery.